Greetings, chemistry students. Today we're going to start the second part of our unit on moles, which is all about percent composition and empirical formulas. And today we're just going to focus on percent composition, which is a really straightforward concept. So percent composition is also known as percent by mass or mass percent. So it's what percent of a compound does each element constitute on a mass basis. If you understand the basic concept of how percents work, then doing percent composition calculations is really straightforward. You take the mass of, you take how much just one element in the compound weighs, divided by the mass of the entire compound, and you multiply it by 100. So if we look at how we calculate it, first you find the molar mass of the compound. Then you multiply the molar mass of each element by how many atoms of that element are in the compound. And then we divide that number by the molar mass of the compound and multiply by 100. So as an example, let's determine the percent composition of water. So if we want to find the percent composition of water, which is H2O, well, the molar mass equals the mass of hydrogen, which is 1.008 according to your reference tables, times 2, plus the mass of oxygen. So that equals 18.016 grams per mole. So then to find the percent hydrogen, we take the mass of hydrogen, 1.008 times 2, because there's two hydrogens, divided by the mass of the entire thing, 18.016, and then to make it a percent, times 100. Then when we take our calculator, and we do this math, we get 11.19% hydrogen. And for the percent oxygen, we take the mass of oxygen. There's only one oxygen, and we divide that by the mass of the whole compound, 18.016 times 100. And lo and behold, we get 88.81% oxygen. Now, if you think about it, this should make sense that even though water consists of two hydrogens and only one oxygen here, since oxygen weighs 16 times as much as hydrogen, then the vast majority of the mass of a water molecule is the oxygen, because the oxygen is so much heavier. So if we go back into this example, it kind of walks us through all of this. That's a little bit confusing to understand, maybe compared to what I just showed you. I'm going to show you one more example of how we do a percent composition problem. So I want to find the percent composition of ammonium sulfide. So the first step is to find the molar mass of the compound. So we're going to take the mass of nitrogen times 2 plus the mass of hydrogen times 8, because keep in mind this 2 out here gives us 2 nitrogens and 8 hydrogens, plus the mass of sulfur. So we add all that up. And we get 159.0. Oh, let's see. Helps if I don't do typos in my calculator. We get 68.154 grams per mole. So then to find the percent nitrogen, we take the mass of nitrogen, 14.01 times 2 divided by 68.154 times 100. and we get 41.11% nitrogen. For our percent hydrogen, we take 1.008 times 8, because there's 8 hydrogens, divided by 68.154 times 100, and we get 11.83% hydrogen. And then for the percent sulfur, we take the 32.07 divided by 68.154 times 100, and we get 47.06% sulfur. So this is the percent composition of ammonium sulfide. Tomorrow, we're going to learn about empirical formula calculations, which is when you take percent composition and you work backwards to come up with a chemical formula.